Hello, classmates. Today I'll be talking about chemical weathering. First off, we need to define what is weathering and why is it so important. Weathering is a breakdown of rocks and occurs when they are exposed to the Earth's surface over a prolonged period of time. Two methods of weathering may occur. One is through the physical disintegration of rocks through physical weathering. This is when their chemical composition is not changed. The second is through chemical weathering. This is through the minerals decomposition of minerals and the chemical composition is changed. Weathering is important because it allows for rocks deep beneath the Earth's surface to be exposed to the elements. The processes that shaped our landscape today took millions upon millions of years to sculpt. Therefore, humans cannot see the overwhelming changes that weathering is responsible for in shaping our Earth in a single lifetime. The extent of weathering can be shown in the Appalachian Mountains. The movement of plate tectonics caused this range to form around 480 million years ago, during the formation of Pangaea. These mountains were once the tallest mountain ranges on the planet and stood over 30,000 feet high, taller than Mount Everest today in the Himalayas. However, weather and erosion have worn down these mountains over millions of years. Today, the highest peak in the Appalachian Mountains is Mount Mitchell in North Carolina, which is only 6,684 feet high, shown in Figure B. However, we can see and investigate the slow processes of weathering which create these changes on Earth's landscape. Weathering also breaks down rocks and minerals and creates sediments, which can eventually form sedimentary rock. Weathering also produces one of the most key aspects of life on Earth, soil. Soil is developed by the fragments created by weathering of the bedrock. The soil is based off the deposit of the rocks and minerals around them. Chemical weathering can affect the soil by changing the parent material's composition. Different parent materials can vary on how susceptible they are to chemical weathering, which is based on their crystal structure. The formation of soil is the most important process for life on Earth. The new soil can then be transported by wind, water, and glaciers. Figure C in the slide shows chemical weathering on a limestone wall, and A shows chemical weathering on rocks on the coast. What is chemical weathering? Well, there are two processes, mechanical weathering and chemical weathering. The two processes are complementary to each other, but chemical weathering causes rocks to change more because it changes the rock's compositions, creating a new mineral. The two processes are important to the rock cycle, but after this slide I'm only going in depth with chemical weathering. Chemical weathering occurs when the chemical reactions decompose the unstable minerals in a rock. In turn, the minerals are changed into stable products. Chemical weathering is also more prominent in tropical climate regions where temperature and precipitations are high. Figure B shows rocks affected by water. Chemical weathering occurs mostly because of rainwater. Water is the most powerful dissolver on Earth. When it combines with atmospheric gases and pollutants, it creates acid rain. Acid rain can occur naturally from volcanic ash from eruptions. However, over the past century, humans' reliance on fossil fuels have grown exponentially. This has led to more CO2 to be released into our atmosphere. Therefore, there is more carbon dioxide in the air to fuel the creation of acid rain. The following can determine where chemical weathering takes place. Acid rain, which comes from our atmosphere, storm water, which is from runoff and can be polluted from humans and other minerals, biochemical processes, which is the breakdown of plants and animals, which have effects on iron and aluminum, and rock uplifts and mountain movements, which expose new rocks to moisture, temperatures, and atmospheric conditions. What is acid rain? Acid rain can also affect the amount of greenhouse gases in our atmosphere through a process called carbonation. Carbonation is when carbon dioxide mixes with water and makes carbonic acid. The carbonic acid dissolves or breaks down the minerals in a rock. Here in figure A shows a limestone statue being affected by acid rain. Chemical weathering causes soluble ions to be split, causing their most soluble components, which are sodium, magnesium, and calcium, to be stripped. These ions are then eventually transported and make their way to the ocean, where marine organisms absorb the ions, like calcium, and form hard calcium carbonate shells. The oceans then respond to the loss of dissolved carbon dioxide by absorbing more CO2 from the atmosphere. This relationship can cause the Earth to cool during mountain building eras, causing the formation of glaciers by decreasing the Earth's temperature. Figure B above shows acid rain's effects on limestone, creating small mountain-like landscape. What is dissolution? Dissolution comes from the effects of acid rain. This is when minerals have weak ionic bonds and are highly soluble to water. Non-silicate minerals such as chlorides, carbonates, and sulfates have weaker ionic bonds and are highly soluble. Some examples of highly soluble minerals are halite, calcite, dolomite, and gypsum. Dissolution of these minerals occur when the positive ions of the minerals become attractive to the negative ends of the water molecule, causing the mineral ions to split. This is shown in Figure A. This completely dissolves the mineral and can create new ones. Karst topography is a product of dissolution, and we will go into that in the next slide. Karst topography. Karst topography is an important landscape to human life. Over 25% of humans rely on it for a fresh water source. In the United States alone, 40% of the population depends on it for water. Examples of karst topography are sinkholes and caves. It is important to prevent the aquifers from becoming polluted from groundwater runoff, since so many people depend on it as a fresh, clean water source. The locations of karst topography occur in regions where soluble rocks like limestone, dolomite, and gypsum are prominent. It occurs mostly in humid tropical regions. Florida is well known for its common occurrence of sinkholes. There are numerous caves in the Appalachian Mountains that were formed through dissolution. Luray Caverns in Virginia is an example of karst topography in our own backyard. This occurs when water, carbon dioxide, and calcium carbonate react and the ions become split in the calcium carbonate. Here in diagram B shows how caverns are formed. Caverns contain two main landscapes: stalactites, which form from the ceiling, and stalagmites, which form from deposits on the floor. Stalactites, which are from the ceiling, are formed by small droplets of water that carry dissolved calcite. The new mineral is made up of calcium bicarbonate and drips from the cave ceiling to progressively form these stalactites. The average stalactite grows between 1/4 of an inch to an inch every century, so it takes thousands of years for them to grow, like in the picture in Luray Caverns. Stalagmites, on the other hand, form on the ground of the cave from the deposits dripping from the stalactites. They can eventually form and make columns. Figure C shows the difference between the two. The next type of chemical weathering is hydrolysis. Hydrolysis occurs when the water breaks down minerals by extracting ions from the mineral's crystal structure. It creates a new mineral and only removes the more loosely bound ions from the structure. The ions are easily broken down through hydrolysis and they form the clay minerals. The new clay minerals can weaken the rock and make it more susceptible to breaking because it's in a chalky-like substance. Figure A shows feldspar, and then Figure B shows feldspar after hydrolysis. You can see to the left of Figure B how it has a different surface where it has a chalky-like substance. The mineral feldspar is one of the most common minerals found on land and makes up more than 50% of the Earth's crust. They are in the silicate family group, in which they share a similar crystal structure and physical properties. They contain silicate tetrahedral that are weakly bonded to soluble potassium, sodium, and calcium or calcium ions. When feldspar undergoes hydrolysis, the reaction between the water molecule and the weak ions of feldspar let out a hydrogen molecule by itself. This happens after coming into contact with acidic water that contains hydrogen ions. However, the stronger bonds of aluminum and silicon are not dissolved, creating clay through the process. This process is the main reason for the ocean salinity, which is a key aspect to life in the oceans. The last type of chemical weathering is oxidation. Oxidation is the reaction of rock minerals with oxygen, which changes the mineral composition of a rock. It can weaken the bedrock by making it softer. Olivine is a great example of this. Olivine, after it undergoes oxidation, loses its iron and turns into limonite. Rust is the most common example. Rust affects our lives day to day. It changes the mineral's colors and makes it brittle, making it more susceptible to breakage. It occurs when the iron is exposed to oxygen and water. Over time, rust will completely break down, which causes billions of dollars worth to our infrastructure every year. Last winter alone, an estimated $3 billion worth of damage was caused from rust by the de-icing of our roads and affected our automobiles. Chemical weathering is a powerful natural occurrence, and it can undergo the processes of dissolution, hydrolysis, and oxidation, and it continues and will continue to shape our landscape for many years to come.